Okay, so exponents and radicals review, number 1A. So let's simplify the square root of 12. So the first thing we're going to do is we're going to do a prime factorization on the 12, and we're going to get 4 times 3, and we're going to get 2 times 2. So we're going to take these numbers that multiply together to make 12 and write them underneath the square root. So we're going to have the square root of 2 times 2 times 3. Now, square root of 2 times 2 is the square root of 4, which is just 2. So if we have 2 2's underneath of a square root, again 2 times 2 is 4, and the square root of 4 is 2, so the answer is simply 2 square root 3. Now, we're always going to check our answer on these things and make sure that they are correct. So if we check square root 12, we're going to get 3.46. And if we say 2 square root 3, we're also going to get 3.46, making sure that we have done the correct operation, making sure you check your answer on your calculator so that you know you did the correct process. And if you did not get the same answer on the calculator, then of course it instructs us that we did something incorrectly. Teaching yourself on your own, building skills on how to solve things by yourself. Possibly we did prime factorization wrong. Possibly we did square root of 4 incorrectly. Great. Okay, we have 1B, 2 root 45. Notice this time I didn't write the tiny little 2 for the square root of 45 as I did for the 12, but it's there. So let's take 45 and do a prime factorization. So we're going to have 9 times 5, and we're going to have 3 times 3. So we can write 2 square root 3 times 3 times 5. So we have two 3's underneath the square root. That means that 1 comes out, and we're simply going to multiply it by the number in front. So we're going to get 6 root 5. Circle our answer. Then we're going to check our answer on our calculator. 2 square root 45 is equal to 13.41. And 6 square root 5 is also equal to 13.41. Therefore, we have done it correctly. Always checking your answer on your calculator to make sure that the process that you did was correct. Okay, we have 1C. So we're going to have 1/3 times the 4th root of 80. So we'll do a prime factorization on 80. 80 is 16 times 5. It's also 20 times 4 and a bunch of other things. And 16 is 4 times 4. And then we have 2 and 2, and then we have 2 and 2. So we can write all these numbers underneath the square root. So we have 1/3 times the 4th root of 2 times 2 times 2 times 2 times 5. Now this time, because we have a 4th root, we are looking for 4 identical objects. And the 4th root of 2 times 2 times 2 times 2 is the 4th root of 16, and the 4th root of 16 is simply 2, because 2 times 2 times 2 times 2 equals 16. So we can simply take that 2 out, so we have 1/3 times 2 times the 4th root of 5. So 1/3 times 2, 2 is over 1, and if we multiply the tops, we're going to get 2 is over 1, 2 is over 1, I'm going to erase that and correct it in red. So if we multiply fractions, 1 times 2 is 2, and 3 times 1 is 3, 4th root of 5. Then we can circle our answer and check our answer on our calculator. 1/3, the 4th root of 80 is simply 0.99, and 2/3 times the 4th root of 5 is also 0.99, so we know we've done it correctly. So remember, be very careful as to what is the type of index. If it's a square root, we're looking for 2 identical objects. If it's a cube root, we're looking for 3 identical objects. If it's a 4th root, we're looking for 4 identical objects. Okay, we have 1D, x root 20 x squared. X root 20x squared. Okay, so let's start with 20. And let's do this a little bit different this time. So this time we're going to look for 2 identical numbers that multiply to get that number that you know the square root of one of them. So we know the square root of 4 is 2, so we're going to do 4 times 5. I'm also going to take x and know that it's simply x times x. Sorry, x squared, and I know that's simply x times x. So I can take my root and write the product, which is 4 times 5 times x times x. So because off to the right the square root of 4 is equal to 2, I know that I can just say x times 2. The 4 underneath the square root is simply a 2 on the outside. So notice in ABC, I use the method prime factorization, and this time I use the method perfect squares. It's going to be a lot simpler sometimes. Then notice we also have 2 x's underneath the square root, and x times x is x squared, and the square root of x for now, square root of x squared for now is x, so I can pull out an x times x, and what's underneath the root? 5. So if I multiply the numbers in front, I get 2 times x, which is 2x squared root 5. Circle our answer. Now we could do something crazy like we did in polynomials, whereby when we check our answer, we simply choose an x value. So let's choose an x value. So for example, x could equal 3 star. So then I'm going to put it into the question. So first of all, I have x root 20x squared. Now if I randomly choose x to be 3, I'm going to avoid numbers like 2 and 1, because 1 times 1 is 1, and 2 plus 2 is 4, and 2 times 2 is also 4, so it's very confusing. So I'm now going to substitute randomly 3 in for x. So we get 3 times 20 times 3 squared. So we get 3 times the root of 20 times 9, or 180. So if I say 3 square root 180, 3 square root 180, I'm going to get equal to 40.25. Then if I take my answer, 2x squared root 5, and I take my random x value that I chose, 3, and resubstitute it, 2 times 3 squared root 5. 2 times 3 squared is 9, times 2 is 18. We get 18 root 5. So if I test my answer, 18 square root 5, I'm also going to get 40.25. Now because these two things are equal, we can put a check mark beside our answer. Now we're not going to keep checking our answer by randomly choosing an x value. It's just a very useful skill to know, to be able to check to see if you've done your work correctly with variables. Making sure we did prime factorization correctly, making sure we simplified the radical correctly. It's very confidence building. Okay, 1e. We have 1/2 square root of 27x cubed. So 27 is simply 9 times 3, which is 3 times 3. And x cubed is simply x times x times x. So we can convert the radical, so we have 1/2 times by 3 times 3 times 3 times x times x times x. So now we're going to be looking for pairs of numbers because we're a square root. So we have 2 3's and we have 2 x's. And now we can start to remove these factors. So we have 1/2 times 3 times x, because we have 2 3's underneath the square root, 1 3 comes out. We have 2 x's underneath the square root, 1 x comes out, and we're left with 3x. Then the 3's over 1, the x is over 1. We can multiply the tops, we're going to get 3x. We can multiply the bottoms, we're going to get 2 root 3x. Circle our answer. So again, yes, we could check our answer by choosing an x value, substituting it in for x into the question, substituting it for x into the answer, making sure the same, but we're not going to do that every single time. Okay, we have 1f. 1f. So this is going to be the cube root of 162 x to the 5. So if I take 162 off to the right and do a prime factorization, I can start off with 81 times 2 and 9 times 9 and 3 times 3 and 3 times 3. And we know x to the 5 is simply x times x times x times x times x. So this time, instead of writing all the numbers underneath the root, why don't I start circling numbers off to the right? So we have a cube root, so we're looking for triples. So I have 3 3's and I have 3 x's underneath the square root, meaning I can take out a 3 and an x. I'm left with the cube root of, I have a 2 and a 3 still underneath the square root, represented by this number off to the right and this number off to the right. All the rest of the numbers at the bottoms of the trees, the leaves. And then we have 2 x's left. X times x, represented by these 2 separate x's over here. Then we can clean it up. So we're left with 3x squared. Square root 2 times 3 is 6. X times x is x squared. And we can no longer simplify it any more than that. Okay, 1g. So we have 1 over 6x squared. And then we have a cube root of 189 x to the 7. So 189 is a really weird number. In order to do a prime factorization tree on 189, we're going to have to very carefully start to choose numbers that can be divided. So 189, first things first, 1 plus 8 plus 9 is equal to 18. And because 3 goes into 18, we know 3 goes into 189. So I'm going to do long division. 3 goes into 189. Now obviously if you have a calculator, excuse me, that looks like a square root. I'm going to do that again. So 3 goes into 189. So 3 goes into 18 6 times, and 3 goes into 9 3 times. So we know it's 3 and 63. So I can continue with my prime factorization tree. 189 is 3 times 63. Then we have 9 times 7. Then we have 3 times 3. So again, we have a cube root. So we're looking for triples. So I have 3 3's. and then a 7 left over. And we know that x to the 7 is simply x times x times x times x, that's 7 times. So, let's write that one underneath. That one's going to be a little more difficult. So 1 over 6x squared cube root of 3 times 3 times 3 times 7 times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6 times x. Sorry for running into my work off to the right. Then I'm going to circle triplets. So we have 3 3's, then we have 3 x's, then we have 3 x's again. So that means I can take out, I have 1 over 6x squared out in front, then I can take out a 3, then I can take out an x, then I can take out an x, and I'm left with root 7x. So, all of these numbers are over 1, and instead of, well, I'll multiply them together first. So on the top we have 3x squared, and on the bottom we have 6x squared. Root cube root, I forgot the cube root above. Notice I just put it in, the cube root that I missed above. There we go, cube root below, and we have 7x. Now we have an x squared on the top and the bottom, so we can divide the top and bottom by x squared and cancel. We can simplify the fraction in front. We have 1 over 2, excuse me, I'm in red now. Root 7x, circle your answer. Great, so lots of extra work like working with fractions and exponents along with simplifying radicals. Okay, we have question number 2a. 5 square root 2. Now in the last question we learned, because it's a square root, because the index is 2, that means that we need to put 2 5s on the inside. So we simply get the square root of 5 times 5 times 2. So if I have 1 5 on the inside, on the outside, that means that 2 5s are on the inside because we have an index of 2, the type of root. Okay, so that means that we have the square root of 5 times 5 is 25, times 2 is 50. Circle our answer. So check our answer on the calculator. So if I type in 5 square root 2, I get 7.07. And then when I type in the square root of 50, I also get 7.07. So we know that our answer is correct. Always checking your answer on your calculator, making sure that the process you did was correct. Okay, 2b. So we have -3x square root of 7x. So be very careful with these, because this tiny little 2, not to be confused with x squared, is the square root of 7x. Let me extend that root a little bit. So be very careful with that. So, can we put a negative into a square root? Well, sort of, but not really, so we're not going to. So we start off by saying negative square root. Now, on the outside, I have a 3x, which means I'm going to be putting 2 3x's onto the inside. 3x times 3x. And then we also have a 7x on the inside. So we're going to get negative the square root. 3 times 3 is 9, times 7 is 63. And x times x times x is x cubed. Circle our answer. Notice I didn't put the square root sign twice. Be very careful. Notice we could choose an x value and substitute it into the question and the answer to make sure it's correct, but we did that in the last question one time just to show you how to do it, and feel free to try that on your own. Okay, 2c, we have 1/2 square root 8. 1/2 root 8. So we need to put 2 1/2s on the inside because it's a square root, so I can say square root of 1/2. I'm going to extend my root down, times 1/2 times 8. I'm going to put the tiny little 2 in where the square root is, 2, knowing that that means we put 2 of the thing on the outside on the inside. So the 8's over 1. So that's going to be the square root. If we multiply the tops, 1 times 1 times 1 is 1 times 1 times 8 is 8, and 2 times 2 is 4. Now we can actually cross cancel. So if we divide the top and bottom by 2, we can cancel a 2 and say 1, and we can cancel an 8 and say 4, because 8 over 2 equals 4 over 1. Then we can cancel the 2 on the bottom and the 4 on the top and divide the top and bottom by 2, so we're left with 1 and 2, because 4 over 2 is equal to 2 over 1. So underneath the root, we just have square root 2. Circle our answer. This one doesn't have any variables, so I'm going to actually type it in. 1/2 square root 8 equals 1.41. And the square root of 2 in our answer is also 1.41. Therefore, we know that we've done it correctly. Okay, 2D. So, 2D says negative 7x cube root 6. Negative 7x cube root of 6. Again, this cube root is part of the cube root, not negative 7x cubed. If that was, I'm going to write that way off to the right, you could say negative 7x cubed, but then you'd also have to say the cube root of 6, and we're not doing that right now. Be very careful as to whether or not the little mini number is an exponent or a type of root. So we have a cube root. I'm allowed to put a negative underneath the cube root, again, depending on what x is, but for now it's okay. So we can say cube root, and I'm going to say negative 7x, and I'm going to put 3 of them because it's a cube root. And still times 6. So on our calculator, 7 times, first of all, cube root, a negative times a negative times a negative is a negative. 7 times 7 times 7 times 6 is 2058. And x times x times x is x cubed, and I'm going to extend my root. Circle our answer. Okay. Okay, at the top right of the page, let's do 2e. So 2e says 1 over 3x cube root of 27 x cubed over 8. I'm going to make that look more like a 3. Great, so we have a cube root, so we're going to be putting 3 of these things on the inside. So we're going to get the cube root of 1 over 3x times 1 over 3x times 1 over 3x. Simply putting the thing on the outside, on the inside, the number of the times that the index is. It's a cube root, so that. Then we have still times 27x cubed over 8. So we have a 27 on the top and a 3 on the bottom, so we can divide the top and bottom by 3. And we're left with 9 on the top and 1 on the bottom. Then we can divide the top and bottom by 3 again. And the 9 turns into a 3, and the 3 turns into a 1. Then we have a 3 on the top and a 3 on the bottom. We can cancel those 3's, dividing the top and bottom by 3. Then we have an x cubed on the top and 3 x's on the bottom. We can start by crossing off one of the x's from the bottom, and I can cross off the cubed and say squared. Then I can cross off another x from the bottom. I can cross off the squared and say to the 1. Then I can cross the x off from the bottom and the x off from the top. So go back and work on your fractions if that is difficult. So we have the cube root, a 2-line root. On the top, all we have left is a 1. And on the bottom, all we have left is an 8. Now I can separate these. I rarely go to the right, but sometimes if I run out of space, I go to the right. I usually go down. So I can separate this into the cube root of 1 over the cube root of 8. And the cube root of 1 is 1, and the cube root of 8 is 2. Circle our answer. Okay, question number 3a. So we have 2 cubed times 2 to the 4. 2 cubed times 2 to the 4. Well, we're simply just going to add our exponents. So we have 2 to the 3 times 4 plus 4, which is 2 to the 7. Circle our answer. I'm going to write that exponent again a little bit cleaner. 2 to the 7. So we can obviously check our answer. So on our calculator, we can type in the question, 2 cubed times 2 to the 4, which equals 128. And our answer, 2 to the exponent 7, is also equal to 128. So we know that we are correct. Okay, so we have question number 3b. We have x cubed times x to the 4. Notice I use a dot for times. It's a little bit simpler, then I don't have to adjust my x's. So again, we're simply going to add the exponents, multiplying with the same base. 3 plus 4, and we're going to get x to the 7. Now, how could we check our answer? Well, we could take a random value, like x being 3, and we could substitute it into the question. So we're going to get 3 cubed times 3 to the 4 if x is 3, and 3 to the exponent 4 times, 3 to the exponent 3 times 3 to the exponent 4 is simply equal to 2187, and 3 to the 7 is also equal to 2187, so we know our answer is correct. Randomly choosing a variable. We could have chosen x being 3, 4, 5, 6, 7, whichever number you like. We could have chosen 2, like in 3a, which was exactly the same question but with variables. Always checking your answer when you can. So just like in the last question, we didn't check any questions because we did check our questions in number 1. With variables, we're going to check our questions with numbers all the time. But with variables, I'm just going to introduce how you check your answer and then allow you to be able to do that. Keep in mind, by doing that, you're going to learn so many more skills. Okay, we have 3c. 6a squared times negative 3a cubed. Okay, so when doing these, we're going to do steps. Signs, numbers, letters. In that order, step 1, step 2, step 3. Try to simplify things into simpler steps. So we have a positive times a negative. That's going to be a negative. 6 times 3 is 18. Then we have a squared times a cubed, and we learned in the last 2 questions that we simply add the exponents, so we get a to the 5. Feel free to check your answer by picking a random value for a and substituting the question and the answer and making sure it's correct. But we're good. If any of these initial steps are more difficult, go and look at the more introductory notes, homework, and video. Practice those, then come back and practice the exam review. Okay, we have 3D. 2 cubed times x cubed. This is a trick question. Some people just think, oh, randomly, okay, we just always add our exponents. Well, you can't just randomly make up rules. If we have the same base, yes, we can add our exponents when we're multiplying, but we don't, so we can't. 2 cubed is 8, x cubed is x cubed, and that is our final answer. Be careful, make sure you understand the rules and the foundations. Okay, we have 3E, A, B, C, D, E. Okay, so we have open bracket 2x, close bracket squared, times open bracket 2x, close bracket cubed. So with this specific question, we have the same thing that is underneath the root. Excuse me. I'm just going to get this away. Excuse me. We have the same thing underneath the root, so we can just add the exponent. So I have 2x, brackets around it, 2 plus 3 is 5. Now, on the inside, I'm going to give both exponents a 1. Then I'm simply going to multiply my exponents. 1 times 5 is 5, so we have 2 to the 5. And again, 1 times 5 is 5, so we have x to the 5. 2 to the 5 on the calculator is 32. X to the 5, circle our answer. So we can only do that and add the exponents if the base is exactly the same. So the base was 2x both times, so we could simply add the exponents. Then when we have brackets with exponents, we multiply the exponents. So be very careful with adding the exponents or multiplying the exponents. Okay, 3F. I've run out of space down the page, so I'm going to go off to the right. 3F. So we have open bracket 3x squared times open bracket 2x close bracket to the 4. So this time we don't have the same base, so we have to do other steps. So I'm going to give 3 an exponent of 1, I'm going to give 2 an exponent of 1, I'm going to give x an exponent of 1. Always giving things that don't have exponents of 1 to remind me what the next step is. So now we're going to multiply the exponents. So we have 3 to the 1 times 2 is 2, x to the 2 times 2 is 4, times 2 to the 1 times 4 is 4, 1 times 4 is 4, 2 to the 4, x to the 4. Then I can do partial steps. 3 squared is 9, x to the 4, times 2 to the 4 is 16, x to the 4. Then we can multiply our numbers together. 9 times 16 is 144. X to the, now we have x to the 4 times x to the 4, so we can add the exponents, x to the 8. Just checking, 16 times 9. Absolutely. Perfect. So remember, we can't just randomly do rules because we learned rules before. We have to very carefully think slowly through each one of the steps. This one didn't have the same base, so we couldn't just randomly or procedurally add the exponents like we did in the last question. We had to use exponents rules of multiplying the exponents together, then adding the exponents of the variables after and multiplying the numbers together. Okay, 3G. We have open bracket 5x cubed squared times 7x to the 99, brackets around it, to the 0. So, some people might start multiplying all their exponents together, but I'm going to recognize that something to the 0 is 1. So I don't even have to bother with that term. I can simply give the 5 an exponent of 1. I can multiply my exponents together. I get 5 squared. 1 times 2 is 2. X to the 6. 3 times 2 is 6. 5 squared is 25. So we're going to get 25x to the 6. Circle our answer. So be careful. There's always going to be little tiny shortcuts that can sometimes very simply, much more easily allow you to do the question, and that is one of those. Okay, question number 4a. So we have x to the 3 divided by x to the 3. Well, I don't like that divided by sign. I'm going to use over. X cubed over x cubed. Now we're dividing with the same base. We can subtract the exponents, so we get x to the 3 minus 3. And 3 minus 3 is 0, so we get x to the 0, which is equal to 1. Circle our answer. Again, let's randomly choose an x value, like x equals 5. And let's substitute it in. Notice I put an asterisk because it's not actually 5. Then I can substitute into the question. 5 cubed divided by 5 cubed is 125 divided by 125, which is equal to 1. And the answer is also 1, so we know that the answer is correct. Okay, we have 4b, yay math. All right, we have x to the 5 divided by, I'm never going to write that grade 8 divided by sign ever again, over x squared. We're dividing, so we can simply subtract our exponents. We get x to the 5 minus 2 equals x cubed. Notice I went to the right this time. I'm going to erase that exponent and rewrite it. X to the 3. Notice I went to the right this time. You can go to the right. It's just way prettier going down. But if you sometimes feel like going to the right is going to better use your space, feel free and go ahead and do that. Okay, 4c. We have open bracket 2 to the x, close bracket to the 6. Divided by open bracket 2 to the 2x close bracket to the 3. So we do have the same thing. Oh, I forgot. I just said I'm never going to write the grade 8 divided by sign again. Over 2x to the 6. 2x, excuse me, to the 6 over 2x cubed. And we can simply subtract our exponents. So we get 2x brackets around it to the 6 minus 3, which is 3. Then I'm going to give both things on the inside exponents of 1. Then we're going to get 2 to the 3 times x to the 3, which is simply 2 cubed is 8, x cubed. Notice I went a little bit to the right and then a little bit down. I'm going to erase that exponent and rewrite it. It's a little bit messy. 8x to the 3. Notice I went to a little bit to the right and then went down. Try and avoid going down, then to the right, and then down. Either go down all the time, or right all the time, or sometimes randomly just to the right once, or to the right all the time and then down once. But it's going to be very difficult for you to be studying your homework when you're sometimes going down and sometimes going to the right without a very logical procedure. Okay, 4D. So we have m to the 5 over m squared, which is simply m to the 5 minus 2 is m cubed. We could randomly pick a number like we did in the first question for A, but that is good enough. So remember, lots of these rules we're just building up to get much more difficult rules in the future. Okay, question number 5a. So we have 5a, x squared cubed. So from the last question, we learned that, or the previous, we learned that if we have exponents to exponents, we multiply the exponents together. So we get x to the 2 times 3, which is x to the 6. So remember, when we're multiplying with the same base, we add the exponents. When we are dividing with the same base, we subtract the exponents. And when we have exponents to exponents, we multiply the exponents. Okay, 5b. So we have open bracket 3x to the 3 close bracket to the 4. So again, if I have something on the inside that doesn't have an exponent, I'm going to give an exponent of 1 to remind me that I multiply the exponents. So 1 times 4 is 4, so we have 3 to the 4 times x to the 3 times 4 is 12. Now 3 to the 4 is interesting. Let's do that without the calculator. We have 4 3's. 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. So we get 8 to the 1, 81. Therefore we know, excuse me. Therefore we know 3 to the 4 is equal to 81. So we get 81 x to the 12. Circle our answer. Okay. 5C. So we have open bracket 3 times 4. Notice I use a dot, but in the notes it says a times sign. 3 times 4 squared. So there's going to be 2 different ways we can do this. So I'm going to write this question again off to the right. 3 times 4 squared. So the first one, I'm going to give the exponents of 1, and then I know I can multiply the exponents. So we get 3 to the 1 times 2 is 2, times 4 to the 1 times 2 is 2. 3 squared is 9, 4 squared is 16, and 9 times 16 is 144. Circle our answer. Or I could have done brackets first. 3 times 4 is 12, still squared. 12 squared, 12 times 12 is 144. Notice the answer is the same. Therefore, we're most likely correct. So not only can we do things like type it into our calculator, but we can also do things like perform it in a different operation. So notice we have the method BEDMAS, B-E-D-M-A-S. Now, this is a law that we're not allowed to break, but it doesn't mean we have to exactly perform it in that order. Notice, in the example on the left, I did exponents first, then multiplication second, which is the correct order. But in the example on the right, I did brackets first and exponents second, which again is still in the same order. So just remember, BEDMAS is a preference of operations. You can't break the laws, but we can sometimes do things in different orders. All right. Okay, we have 5D. So we have 2x. That was a funny looking bracket. We have 2x times 3x all squared. Now again, in the last question, we learned that we can either do exponents, then the multiplication, or we can work on the brackets first and do the multiplication before the exponents. So 2 times 3 is 6. X times x is x squared, and then we are still squared. I'm going to give the exponent, give 6 the exponent of 1, and remind me that we multiply the exponents. 6 to the 1 times 2 is 2. X to the 2 times 2 is 4. 6 squared is 36. X to the 4. Circle our answer. Okay, we have 5E. So we have open bracket 3xy close bracket squared. So I'm going to give everything exponent of 1. And this time I'm going to skip a step. 3 squared is 9. Then we have x squared multiplying our exponents together. Then we have y squared multiplying our exponents together. Circle our answer. So remember, we can skip steps. I didn't have to do 1 times 2 is 2 and then do 3 squared. We know that 3 squared is 9, so if you'd like to do that, feel free. Okay, 5F. Notice I'm up a bit to the right. Excuse me, I ran out of space. 3x times 2y, brackets around it, squared. So again, I'm going to start on the inside. 3 times 2 is 6. X times y is xy. Brackets around it, still squared. Kind of tough to see that squared. 6 squared is 36. x squared is x squared, y squared is y squared. Circle our answer. Okay, 6A. We are going to be looking at some repetitive questions here. So let's take -2 squared. Now that is just a negative in front of 2 times 2, which is just equal to -4. So just because the exponent is even doesn't mean it always becomes positive. That negative is not being squared. For example, if it was like this, then that would mean that's -2 times -2, which would equal +4. But in the first part, the negative is not being squared. Okay, B. So let's take -5 cubed. -5 cubed. So I'm not going to write out the multiplication each time. We're cubing the negative, which means we're going to be negative, and 5 cubed is 125. Check that on your calculator. Check all of them on your calculator. C. -3 to the 4. This time we're taking a negative to the 4th power. We're taking a negative to an even power, which means we have 4 negatives, and that means that the answer is going to be positive, and 3 to the 4 is 81. I know that because 3 times 3 is 9, times 3 is 27, times 3 is 81, or 9 times 9 equals 81. Much easier to look at it that way. Okay, D. So -7 squared in brackets. So inside the brackets, first of all, we have a negative outside of the brackets. Inside the, you know what? I'm going to go down the page. I'm going to go down the page because it's prettier. So we have a negative out in front, and we have -7 squared on the inside, which is -49. Then we have a negative times a negative, which is a positive, and we're going to get +49. So be careful with interesting locations of squares, cubes, etc. E. So we have -4 cubed. So first of all, we have a negative outside the brackets. I'm going to carry that down. Then I have a negative cubed, which is a negative, and 4 cubed is 64. Check that on the calculator. And we have a negative, so that means that's positive 64. Circle your answer. Okay, F. We have a F. We have a negative in front of -1 to the 4, which means we have a negative out in front of the brackets. I'm going to put that first. Negative to the 4 is a positive. 1 to the 4 is 1. Then we have a positive and a negative side by side, which means that's a negative. -1. Circle your answer. Check your answer on the calculator. I'm going to go up parallel now. I kind of ruined my system, but I'm going to go up and make a second column up at the top right-hand corner here, G. -8, close bracket squared. Now, these brackets are absolutely unnecessary. We're not squaring any negatives on the inside, so therefore it's just -64. 8 squared is 64 with a negative in front. I'm going to skip this side work I did and keep working off to the right here. H. Oh, the question says -9 squared, and that's just +81. All right. Okay, we have 7A. Exponents with variables, -2x squared. So if we take this, and first of all, we're going to square the negative, which negative times a negative is a positive, so it becomes positive. Then I'm going to give both things the exponents of 1, and then we're going to multiply our exponents. So we're going to get 2, and 1 times 2 is 2, and x, and 1 times 2 is 2. Then 2 squared is 4, and x squared is just x squared. Circle our answer. So again, remember, check your answer if you want to. X is 7. Who knows? So Let's usually don't, you know what? Don't usually choose 7. I'll just show you. So take the question, negative 2x all squared, and take the answer, 4x squared, and take 7 and plug it into both. Substitute with brackets, 7. I'm going to make that cleaner. 7 squared. So brackets first. Negative 2 times 7 is going to be negative 14. And squared is going to be 196. And if I take 7 and I put it into the answer, I get 4 open bracket 7, close bracket squared. And that's going to be brackets first for bedmass. So 7 squared is 49. With a 4 in front is also 196. So we can put a check mark beside our answer. Again, I'm not going to be checking all of the answers. I just want to show you that you can all the time with expressions, equations, all the time. So 7b. So we're going to get negative 3 x brackets around it cubed. So this time we're cubing a negative, so we're going to get a negative. And then I don't have to give the things on the inside an exponent of 1. I'm just multiplying the exponents, but it's really just 3 cubed, which is just 27. And then we have x cubed. Circle our answer. Check your answer if you want to, or check my answer. Okay, 7c, we have negative 2x squared y cubed, all cubed. So the 2 on the inside has an exponent of 1, so I'm going to give it an exponent of 1 to remind me that I'm multiplying the exponents. Now we have a negative inside the brackets being cubed, therefore a negative cubed is a negative. Then we have 2 to the 1 cubed. Well, that's really just 2 cubed, and that's just 8, so we don't really have to do that every single time. So now we're going to multiply the exponents. So we have x to the 2 times 3 is 6, then we have y to the 3 times 3 is 9, and we can circle our answer. Negative 8, x to the 6, y to the 9. Okay, 8a. So we have x over y all squared. Well, I'm going to give both things on the inside an exponent of 1. And we're simply going to multiply the exponents. We're going to get x 1 times 2 is 2 over y to the 1 times 2 is 2, distributing exponents to both things. Now, notice I did go to the right there. Most of the time I do go down the page, yet sometimes if it's just going to be one single step, I will go to the right. So we're going to have b. So we have 3y over 2x all squared. So you can give the numbers exponents of 1 to remind you that we're multiplying the exponents, but 3 squared is 9. Then we have y on the top. Y squared is just simply y squared over 2 squared is 4, and x squared is just x squared. Circle our answer. 9y squared over 4x squared. Pardon my funny writing sometimes. It's very difficult to write on this whiteboard. Okay, C, we have 12 cubed over 3 cubed. Now this is an interesting question. There's many ways to do this question. Now, does anybody know what 12 cubed is? It's a very difficult answer. Now, because both of these things are being cubed, we can actually do an interesting step and simplify. Because if it was the other way around, if I was going in the other direction, I would multiply my exponents. Both things have an exponent of 1 on the inside. Therefore, we're going to get exactly the same as the question, so that's allowed. Now, on the inside, we have 12 divided by 3 is 4, and that's still in brackets being cubed, and that's going to be 64. Circle our answer. Feel free to check that answer on the calculator. So that's just a reminder of an interesting method that you can do. You don't always have to do things in exactly the order in which they teach you to do them. Feel free to do anything that you want. You just can't break the laws. Okay, D. So we have 6x squared over 2x. I'll give it a 1. All cubed. So this time you may ask, what do we want to do first? Well, first of all, I'm going to go down the page this time. And do I want to cube 6? Do I want to cube 2? Do I want to cube the x's? No, I'd rather simplify the inside first. 6 divided by 2 is 3. X squared divided by x is x to the 1. If I subtract the exponents, 2 minus 1 is 1, or simplifying using multiplication because x squared over x is equal to x times x over x, and x divided by x is 1, so I can cancel, and that's why it's just x. So we get 3x to the 1 all cubed. Remember, if you can simplify the inside, always do it first. 3 cubed is 27, and x 1 times 3 is 3. Circle our answer. Okay, E. So we have 180 x squared over 6x all squared. Again, simplify the inside if you can. 18 divided by 6 is 3. We have a 0 attached. Then x squared divided by x is just x. Brackets around it, still squared. 30 squared is 900 x squared. Circle your answer. So we have F. I'm going to do that up top because I am too tall. So we have F. So we have 5xy over 35 y squared. Brackets around it, squared. So again, I could multiply the exponents, but I'd rather simplify the inside first. If I divide the top and bottom by 5, I'm going to get 1 over 7. I have an x on the top, I'm going to leave it. I have a y on the top, and a y times a y on the bottom. Y squared is y times y. I can cancel them, I'm left with a 1 on the top. So that means I just have a y on the bottom. Now this is still being squared, so I'm just left with x squared over 7 squared is 49. And I have a y, and I'm going to square it on the bottom as well, multiplying my exponents together. Again, if you feel necessary, give exponents of 1 to things that you're unfamiliar with. Okay, great. So that's multiplying the exponents, distributing the exponents into the top and the bottom, making sure that we simplify first. If any of these rules are difficult, make sure that you go back and watch the more introductory videos below. Okay, we have 9a. Write with positive exponents. So we have x to the negative 4. Remember, we're going to bring it to the bottom and make the exponent positive. Notice I don't put anything on the top until I'm ready to put something on the top. There's a 1 on top. Circle your answer. We could randomly check an x value if we like we've done in the past, but let's not. Okay, b, 1 over b, 1 over x cubed. So, 1 over x to the negative 3. I'm going to clean that up. X to the negative 3, which means that if I have a negative exponent at the bottom, I'm going to start off with a fraction, and I just bring it to the top and make the exponent positive. Now, I could leave a 1 on the bottom, but I don't have to. My answer is just x cubed. Okay, C. 2x to the negative 2. 2x to the negative 2. Again, I'm working with negative exponents, so I start off with a fraction. Now, x has a negative exponent. X to the negative 2. I'm going to bring that down to the bottom and make the exponent positive. Now, 2 is just on top. I'm going to leave it there. It doesn't come down if it doesn't have a negative exponent. Okay, D. So we have 2 to the negative 3, x. So again, we have negative exponents. I'm going to start off with a fraction. Now, first of all, x is on the top. It doesn't have a negative exponent. I'm going to leave it there. Now, I have 2 to the negative 3. I'm going to bring it down to the bottom and make the exponent positive. And 2 cubed is simply 8. Circle our answer. So be really careful. The thing with the negative exponent comes to the bottom or the top and becomes positive, but things without negative exponents stay where they are. Okay, E. So this time we have 3x to the negative 3. Well, this time I'm going to go down the page, and this time the whole thing has brackets around it to the negative. So again, negative exponents, I'm going to start off with a fraction. And the thing with the negative exponent, I'm going to bring to the bottom and make the exponent positive. So we're going to get 3x, brackets around it, cubed on the bottom. And we're just going to get a 1 on top. So we brought the thing with the negative exponent, the whole thing with brackets down to the bottom, made the exponent positive. This time I'm going to go to the right. Remember, only go to the right if it's a final step. So we have 1 over 3 cubed is 27, and x cubed is x cubed. Okay, we have f. So 2 to the negative 3, x to the negative 2. So again, we have negative exponents. I'm going to start off with a fraction. Now they both have a negative exponent, so I'm going to bring them both down to the bottom, make them both exponents positive. So we're going to get 2 cubed, bringing the exponent down, making it positive, x squared, bringing it down, making it positive, put a 1 on top, equals 1 over 2 cubed is 8, and we still have just an x squared. Circle our answer. Okay, G. We have 1 over 3x to the negative 2. 3x to the negative 2. So again, we have negative exponents. I'm going to start off with a fraction. Now there's a 3 on the bottom. It doesn't have a negative exponent. I'm going to start by leaving it on the bottom. X has a negative exponent, an exponent of negative 2. I'm going to bring it to the top and make the exponent positive. So we're going to get x squared on the top. Circle your answer. Now let's keep our nice clean column system going. So GH. So this time we have 5 over 2 to the negative 3, x to the negative 2. 2 to the negative 3, x to the negative 2. Now again, we're going to start off with a fraction. So we have a 5 on the top. I'm going to leave it there. Now we have a 2 to the negative 3. I'm going to bring it up to the top and make the exponent positive. So times 2 cubed. And x has a negative exponent. I'm going to bring it to the top and make the exponent positive. So we have x squared. Now I'm going to leave a 1 on the bottom. So we're going to multiply. Exponents first. 2 cubed is 8 times 5 is 40. 40x squared. Circle your answer. Okay, I. So we have 2 over 3x, brackets around it, the negative 2. So the 3x has a negative exponent. I'm going to bring it to the top and make the exponent positive. So negative exponents, I'm going to start off with a fraction. We have a 2 on the top. I'm going to leave it there. We're going to bring the 3x to the top and multiply and make the exponent positive. So we have 2 times 3 squared is 9, and then we have x squared. Notice I didn't even bother putting a 1 below it. I just kept doing my work and forgot that the over was there. I could scribble it out if that makes you feel better, but it doesn't even matter. So 2 times 9 is 18 x squared. Actually, I think it was a bad idea that I wrote it there and didn't put the 1 on the bottom. It was a good idea to scribble it out. Okay, J. So we have x squared over y to the negative 3. So again, we have negative exponents, so I'm going to start off with a fraction. Now x squared's on the top. It has a positive exponent. I'm going to leave it where it is. Y to the negative 3 is going to come up to the top. And this time the over's there. I'm going to leave it there, but I'm not going to put a 1 underneath of it. I'm not going to scribble it out. I'm just going to circle my answer. Who cares if it's there? Okay, K. So we have negative x to the negative 1. Brackets around it squared. So I have a negative exponent on the inside. I could, first of all, bring it to the bottom and make the exponent positive. Carry everything else down. Then I could square the 1. 1 squared is 1. Then we're going to get x to the 1 times 2 is squared. So over x squared. Circle our answer. Or we could have just instead multiplied our exponents right away. Negative 1 times 2 is negative 2. Then we have x to the negative 2, which is 1 over x squared. Just reminding you that you can do anything in any order that you want. You just can't break the rules. Okay, so that was negative exponents, writing things with positive exponents. If it's got a negative exponent on the top, comes down to the bottom, exponent becomes positive. If it's got a negative exponent on the bottom, comes to the top, exponent becomes positive. If there's a number or a letter anywhere with a positive exponent or no exponent, like an exponent of 1, it would just stay exactly where it was and not come. Either way, if we're going to be using negative exponents, we're always going to start off with a fraction, just to remind ourselves, get that muscle memory going, and put the negative exponents where they belong and make the exponents positive. Okay, 10A. So this question is just to sort of remind us that we can't just randomly start bringing negative exponents all over the place and breaking the rules. So we have 2 to the negative 2 plus 1 all over 2 cubed. So I'm going to erase that exponent on the top and make it a little bit cleaner. So that's 2 to the negative 2 on the top. So we have negative exponents. So I'm going to start off with that 2 to the negative 2. Now, 2 to the negative 2 confuses me a little bit. So I'm going to start by writing it off to the right all by itself and working on it. So 2 to the negative 2 is actually over 2 squared with a 1 on top. And 1 over 2 squared is just 1 over 4. So I'm going to start with that. 1 over 4 plus 1 all over 2 cubed is 8. Okay, so first of all, I could add the fractions. Let's start there. 1 over 4 plus 1. The 1 is over 1. If I times the top and bottom by 4, that becomes 1 over 4 plus 4 over 4, which is just simply 5 over 4. So on the top, we can say 5 over 4. Now the bottom, the 8 is over 1. Now in dividing fractions, so 5 over 4 divided by 8 over 1 is simply equal to 5 over 4 times 1 over 8, which is simply equal to 5 over 32. So the answer to this question is 5 over 32. Circle our answer. Now, this is going to be a little bit more difficult to check our answer. So in order to type it in the calculator, we have to make sure to put brackets around the top and brackets around the bottom in the question, like I just did in red. So if I type that in exactly like that, bracket 2 to the exponent negative 2 plus 1, close bracket, divided by 2 cubed, and I'm going to get 0.15625. Now I'm going to type in the answer, 5 divided by 32, and I'm going to get 0.15625. So I know my answer is correct. Now, I'm going to start it from here. So we have 1 over 4 plus 1 all over 8. Now the 8's over 1, and the 1 on the top's over 1. And we have a method called times the top and bottom by the lowest common denominator. And the lowest common denominator between 4, 1, and 1, all of the denominators, is 4. So I'm going to times the top by 4, and I'm going to times the bottom by 4. Now I'm going to times the first fraction. I'm going to do that off to the right. 1 over 4 times 4. Well, I can cross cancel, or that's equal to 4 over 4 anyways, which equals 1. So I can put that back into the question. And then 1 over 1 times 4 is just 4. And 8 over 1 times 4 is just 32, which means my answer again is 5 over 32. Circle our answer, and we know it's correct. So that was a method called multiply the top and bottom by the lowest common denominator. That will clear a complex fraction for you, instead of having to add fractions on the top and possibly on the bottom and then flip and multiply. It's a great method to practice. And that's exactly what we're going to do with this next question. So we have 10b, x to the negative 3 plus 1 all over x squared. Notice it's a very similar question to the question above. So x to the negative 3 is 1 over x cubed. Then we have plus 1 all over x squared. The x squared on the bottom is over 1. Then the 1 on the top is over 1. The lowest common denominator is x cubed. I'm going to times the top and bottom by x cubed times x cubed times x cubed.
Then, again, we're going to do that. So I'm going to go to the right because I don't have any space. When I multiply the first fraction, 1 over x cubed by x cubed, the x cubes cancel. I'm left with 1. Then when I times the 1 by x cubed, I get x cubed. And on the bottom, I'm going to get x squared times x cubed, which is just x to the 5. And if, for example, I randomly decide, I'm going to circle my answer. If, for example, I randomly decide to choose a value like 2 for x and substitute it into the question, asterisk, because it's not actually 2, substitute it into the question and into the answer, well, that's actually exactly the same question as above. And if I put into the answer, oh, no, it isn't exactly the same. So, sorry about that. It isn't exactly the same question. The exponents are switched up a little bit. So I have to try it. So I'm going to start by putting it into the question and then into the answer. So, again, sorry about that. I'm going to do it on the calculator. So I'm going to get open bracket on the top. Brackets are on the top. Brackets are on the bottom. I'm going to get open bracket 2 to the exponent negative 3. Plus 1, close bracket, divided by 2 exponent squared. The brackets are on the bottom are not necessary because there's no plus or minus sign. Enter. I'm going to get 0.28125. Then I'm going to put it into the answer. So that's going to be 1 plus 2 cubed. 2 cubed is 8. 1 plus 8 is 9. 2 to the 5. 2 to the 5 is 32, and 9 divided by 32 is also equal to 0.28125. So we can check our answer. Sorry about that, I got a little bit confused. I thought the questions were extremely similar, but they weren't, as the exponents on the top and the bottom are a little bit switched, and some other things. Great, so do not always just confuse negative exponents with bring it to the bottom, make the exponent positive. It's a very separate sort of feature, and as I did at the beginning off to the right, showed you exactly what it meant, and when I brought it back into the question, I made a complex fraction. Okay, great. Okay, number 11, change from radical root form to exponential form. So we have 11a. Which says the 5th root of 3 squared. Now, the forms we have to memorize are that the nth root of x to the m is equal to x to the m over n. That's the only time I'm going to use an angled slash fraction is when it's in the exponent. Okay, so that is the rule. I like to remember the bottom becomes the root. Some people like to remember the top stays as the exponent, or both. So this will simply equal 3 to the 2 over 5. Circle our answer. Now, of course, check your answer on the calculator. If I type in the question, the 5th root of 3 squared, I get 1.55. And if I type in the answer, 3 to the exponent, 2 over 5, I'm going to get the same 1.55. So we know that we are correct. Okay, B, square root 6. So I'm going to put some numbers that aren't actually there. So we have a square root, so that's a little 2, and 6 as an exponent of 1. So then I can convert it using the same formula as we just did in the top right. And we're going to get 6 to the 1 over 2. Circle our answer. We can check our answer by doing the square root of 6 and getting 2.45. And then doing 6 to the exponent, 1 over 2. And also getting 2.45. Therefore, we know we're correct. Always, always check your answer if it's just numbers. It's so easy. If you have variables, yes, it is more difficult, but okay. So let's go for C. So this is going to be the square root of x to the 5. So x, the bottom becomes the root and the exponent becomes the top. So we get x to the 5 over 2. Circle our answer. So with that one, we could check our answer by picking a random value like 3 star. X isn't actually 3, we're just checking our answer, and that would be the square root of x to the 5. And the answer, x to the 5 over 2, which would be the square root of, brackets around it, 3 to the 5. And 3 to the 5 is 243, so that's the square root of 243. And the square root of that is 15.58. Whoops, 15.58. And then if we type in the answer, we're going to get 3 to the 5 over 2. And 3 to the exponent, 5 over 2, is also 15.858. Therefore, we know our answer is correct. Check mark. So, changing forms. Changing from radical form to exponential form and vice versa. Being able to go back and forth, which we're going to do a little bit more on the next one. And then continue into some more difficult combination radical questions. Radicals and square roots are both the same. Okay, 12a. So change from exponential form to radical or square root form and simplify if possible. So we're going to get 9 to the 5 over 2. So we can convert that. I'm going to go down the page this time. So that's going to become the square root of 9 to the 5. Using the same formula we were in the last time. X to the m over n is equal to the nth root of x to the m. Remembering that either the bottom becomes the root or the top stays the exponent. Now we don't know what 9 to the 5 is, so we don't want to do that, but we do know what the square root of 9 is. We always want to do the root first if we can. So the square root of 9 is 3, and 3 to the 5 is 243. I'm going to check that on the calculator. So we have 9 to the exponent, 5 over 2, which is 243, which means our answer is correct. Okay, B. B is an interesting little tricky looking question. So it says 9 to the 0.5. Well, we know that that's just a fraction, so that's just 9 to the 1/2. And that will become the square root of 9 to the 1, which is just the square root of 9, which is just 3. And we can check our answer on our calculator. 9 to the exponent 0.5 equals 3. Therefore, we know the answer is correct. Okay, C. 27 to the 0.3 repeater. So that's just 27 to the 1/3. And the cube root of 27, and that's just the cube root of 27 to the 1, and the cube root of 27 is just 3. So just because it's called radical form, square roots with fractions, doesn't mean we can't convert back and forth between decimals. So if you have difficulty with that, just test it on your calculator and just try stuff until you get it, like 2 divided by 3, 1 divided by 3, etc. Or learn to convert them properly back in decimals, fractions, and whatever in grade 8. Okay, D. So we have -3 to the 2/3. So this negative is not being taken to the exponent, just way out in front. Then I can convert it. That's just the cube root of 3 squared. And 3 squared is 9, so that's just negative cube root of 9. Circle our answer. So if I type in the question, -3 to the exponent 2 over 3, we're going to get negative 2.08. And then if I type in the question, I'm going to get negative cube root of 9, which is also negative 2.08, which means our answer is correct. Okay, it's getting a little bit low for me, so I'm going to go up top here. E. Nice 2-column system, 3 columns if you probably fit it on your graph paper. So 16 to the 3 over 4. So that's going to become the 4th root of 16 cubed. And again, I don't know what 16 cubed is. I'd rather take the 4th root of 16, which is just simply 2. Cubed is simply 8. And if I type that question into the calculator, 16 to the exponent 3 over 4 is simply equal to 8. Check mark. Okay, we have 81 to the negative 3 over 4. So we have a negative exponent, so we're going to start off with an over. I'm going to bring the thing with a negative exponent down to the bottom and make the exponent positive. We get 81 to the 3 over 4. And then there's just going to be a 1 on top. Now I can convert it. So we have 1 over the 4th root of 81 cubed. And I don't know what 81 cubed is, but the 4th root of 81 is 3, so we're 1 over 3 cubed. If that stuff's difficult, write it off to the right. The 4th root of 81 is equal to 3, because 3 times 3 times 3 times 3 is equal to 9 times 9, which is also 81. Now, 1 over 3 cubed is simply 27, and we can circle our answer. Then, on the calculator, we can say 1 divided by the 4th root of, 80, the question, I was going to type in the second line, 81, the question, 81 to the exponent negative 3 over 4, enter, which equals 0.037 repeater. And on the calculator, the answer, 1 divided by 27, is also 0.037 repeater. Therefore, we know we are correct. Okay, G. So, whoops, we have negative 125 to the 5 over 3. So, let's just convert this thing. So we have the cube root of bracket negative 125 to the 5. So, we have the cube root of 125 to the 5. So do we know what 125 to the 5 is? No. But we know the cube root of negative 125 is just negative 5. Brackets around it to the 5. And a negative to the 5 is a negative. And 5 to the exponent 5 is 3,125. Circle our answer. And then type in the question. Equals, open bracket, negative 125, close bracket, the exponent 5 over 3, and we're going to get negative 3125, making sure our answer is correct. Check your answer. So lots of work with fractional exponents there, working with the basic laws of changing the different forms from exponential form to radical form and vice versa, like in the last question. And then also incorporating a little bit of negative exponents and negatives. Remember, we cannot square root a negative. So I'm just going to do a question on the bottom left-hand corner here. I'm going to call it 99. Remember, if there's a negative inside the square root, there is no solution unless there's a variable and the variable is also negative. Long story. You cannot have a negative number inside a square root all by itself. No solution. Okay, 12H. Some more negatives with exponents. We have negative 5 to the 3 over 2. So we can convert it. So that's going to be the square root, open bracket, negative 5, close bracket, cubed. Now, we can't square a negative. I'm going to do the cubed anyways, just to show you a further step, but I know the answer is no solution already, because we can't have a negative on the inside of a root that's an even root if it's inside brackets, even if it's cubed, because if it's squared, for example, on the inside, then it would clean itself up. I'm going to show you that after in just 1 second. So if we do that, cubed on the inside, whoops, square root of negative 125, again, no solution. We can't square a negative. If, for example, the question was extremely similar, but it was negative 5 to the, for example, 4 over 2. So now I know the exponent 4 divided by 2 is 2, and would just be 2 anyway, so I'm just showing you this for the point of it. So I'm going to convert it, so it's the square root of negative 5 to the 4. Now, I can take the negative on the inside to the 4 first, which becomes a positive. 5 to the 4 is 625. And then I can say square root that. Now, I'm going to do a method from earlier, simplifying a square root. So 625 is 5 times 5 times 5 times 5. And the square root of 5 times 5 times 5 times 5, we have two identical numbers underneath the root twice, which becomes 5 times 5, which is just 25. Circle our answer. And if we type that into the calculator, negative 5 brackets around it to the exponent 4 over 2, which is just squared, we also get equal to 25. So we know that we're correct. So I just showed that. I'm going to call that another 99. Anytime I do a question that I'm just throwing in to show an additional piece of information, if that happens, it's allowed to have a negative on the inside, but most of the time you're not allowed to have a negative inside an even root, because we can't even root a negative. Okay, I. So we have negative 5 to the 3 over 2. Now this negative is so far out in front, I don't even care. It's not in brackets. Now I'm going to convert. Square root of 5 cubed. Now I don't know what the square root of 5 is, but I do know what 5 cubed is, and that's 125. But I'm going to use prime factorization to simplify it out. So it's negative square root 5 cubed is 5 times 5 times 5. Which means that I can simplify the root. I have two identical numbers on the inside, 5 times 5, which means it's just going to be negative 5 square root 5. Lots of different ways to write this. If they just tell you to change forms, the second line may be good, but if they're always asking you to simplify all the way, you might have to always go this far. Okay, J, we have negative 8 over 27 all to the 2 over 3. So we can convert it. So this is going to be a two-line root. So we have the cube root of negative 8 over 27 all squared. Now on the inside we're cubing negative 8. So we're going to cube the negative, so we get a negative because you can cube root a negative and it becomes negative. Then we have the cube root of 8 is just 2. Then we have the cube root of 27, which is just 3. Then I'm squaring it. If I square a negative, I get a positive, so it's going to be positive. 2 squared is 4, and 3 squared is 9. Now if I type in the question, I'm going to have open bracket, negative 8 divided by 27, close bracket to the exponent 2 divided by 3, and I get equal to 0.4 repeater, and the answer is also 0.4 repeater, so we are correct. Okay, K. So we have a two-line root. We have 3 to the 4 over 3 squared. Remember, we'd rather simplify on the inside if we can. We're dividing with the same base, so we can subtract our exponents. We're left with 3 squared inside a square root. Now, the square root of 3 squared is just 3. It is the reverse operation. You could do prime factorization. 3 squared is 9, and then the square root of 9 is 3. But the square root of 3 squared is just 3 because it's just a reverse operation. L. 9n squared to the 1/2. So on the inside, I'm going to give the 9 an exponent of 1. Then I'm going to multiply the exponent, so we get 9 to the 1/2. And then n, 2 times 1/2 is simply just 1. Now 9 to the 1/2, I'm going to convert it. That's the square root of 9 to the 1. And we just have n, and the square root of 9 is 3. And we can just say 3n. You could check your answer by picking a random variable for n and substituting into the question and the answer, but I will let you do that on your own. Okay, m. So we have 32 x to the 10 all to the negative 1 over 5. So I have so many different options, but I don't like negative exponents, and this whole thing is inside brackets, so I'm going to bring the whole thing down to the bottom. I have a negative exponent, so I'm going to start off with an over. Then this all is being brought to the bottom, and the exponent is made positive. Put a 1 on top. Okay, the 32 on the inside has an exponent of 1. I'm going to multiply the exponents together, so I'm going to have 1 over 32 to the 1/5. X to the, now 10 times 1/5 is simply just 2. If you have difficulty multiplying fractions and remembering that numbers are over 1, go back and review fractions in grade 8. Okay, now I can convert it. So we have 1 over, we have the 5th root of 32, all by itself on the bottom, x squared. The 5th root of 32 is just 2. Because 2 times 2 times 2 times 2 times 2, 5 2's multiplied together is 32. 1 over 2x squared. Circle your answer. Okay, these things are getting complicated looking. Okay, so we have m. So we have negative 27. X to the 9, y to the negative 3, to the 4/3. So, this time I'm going to turn the number all by itself, 27, negative 27, brackets around it, to the 4/3, which I'm going to convert right away, which is the cube root of negative 27 to the 4. Just starting off on the number all by itself, giving the exponent and changing to root form at the same time. Okay, now I'm going to multiply my exponents together. 9 times 4 divided by 3 is 9 divided by 3, which is 3 times 4, which is 12. So we're going to get x to the 12. Then we'll have y to the negative 3 times 4 over 3 is simply 3 divided by 3 is 1. Cross canceling, we're going to get negative 4. Then we can continue working on it. So I have a negative exponent, so I'm going to start off with a fraction. So the cube root of negative 27 is just negative 3, still to the 4. We have x to the 12. And then y to the negative 4, we're going to bring down the bottom, make the exponent positive. And negative 3 to the 4 is a negative to the 4, which is a positive. A negative to an even exponent is positive. So we get positive. 3 to the 4 is 81. And we have x to the 12 and y to the 4. Circle our answer. So a lot of work there with radical exponents, brackets, negatives, changing forms. Okay, so we have the square root of the square root of 81. So I'm going to put tiny little 2's in the locations of the square roots to remind me what to do. And I'm going to start by working on the inside. So I haven't touched the outside, so I'm going to leave it. We have the square root. Now, the square root of 81 is simply 9. Then I can just take the square root of 9, which is just 3. So working on roots inside roots. So this time I'm going to do a little bit differently. So if I take the question P, we're going to do the square root of the square root of 512 x to the 5. So if we start off by instead changing forms. So 512, first of all, I'm going to give the exponent, give the radicals tiny little 2's. Then I'm going to start on the inside. So we have 512 x to the 5. Brackets around it. Now, this thing really has brackets around it to the 1, because the 512 doesn't have an exponent of 5. So that means that this thing has an exponent of 1 over 2. Now, it still has a root around it. And we know another root around it is just another exponent of 1/2. So then I can go down the page. I have exponents to exponents, so I can multiply my exponents. 512 x to the 5. 1/2 times 1/2 is just 1/4. Then I can multiply my exponents back in, and I'm going to convert at the same time. So that's the 4th root of 512 x to the, multiply my exponents together, 5 over 4. I'm going to make that a little bit cleaner. Lost a bracket from above accidentally, to the 5 over 4. Now, on my calculator, I'm going to do the 4th root of 512. 4th root of 512. And I don't get a pretty answer. So I'm just going to leave it like that. All right, square roots, radicals, changing forms, negative exponents, negative coefficients, squaring and cubing negatives, all sorts of stuff all wrapped up into one. Okay, so now we're going to bring in some more of the more basic exponent laws we learned with radicals multiplying with the same base.
All right, we have 13a. So we're going to have 3 to the 1 over 3 times 3 to the 1 over 2. So if we remember from earlier that if we're multiplying with the same base, we can simply add the exponents. So these are fractions that we should add off to the right. 1 over 3 plus 1 over 2. We need a lowest common denominator of 6, so over 6 plus over 6. And we times the top and bottom of this fraction by 2, by 2, and the top and bottom of this fraction by 3. So if I do that, I'm going to get 2 plus 3, which is equal to 5 over 6. So we're going to bring that back into the question. The answer is 3 to the 5 over 6. Circle your answer, unless they've informed you to turn it into root form. Okay, 13b. So we have 5 to the 1/2 times 5 to the 1/4. Again, we're going to add fractions, so we have 1/2 plus 1/4, multiplying with the same base, add the exponents. This time, the lowest common denominator is 4, and I'm going to skip a couple steps. So times the top and bottom of this fraction by 2. That means that we are over 4, and 2 times 1 is 2, plus 1 is 3, and the answer is 5 to the 3 over 4. Circle our answer. So in the last question, I forgot to check my answer, so I'm going to do that really quickly. Typing the question into the calculator, 3 to the 1 over 3 times 3 to the exponent 1 over 2. And if we type that in the question, we're going to get 2.49, 2.50. And if I type the answer, 3 to the exponent 5 over 6, I better get exactly the same thing, equals 2.49, which means we are correct. On the next question, 5 to the exponent 1 over 2 times 5 to the exponent 1 over 4 equals. So that answer is 3.43. And if we do 5 to the exponent 3 over 4, we're also going to get 3.43, which means that we are correct. Always checking your answer when you can. Reminds you that you did the correct fraction operations, that you added the exponents correctly, etc. Okay, we have C. So we have the cube root of 5 squared times the square root of 5 cubed. So the first thing that we're going to do is we're going to follow the pattern that we learned in the last example, where the nth root of x to the m is equal to x to the m over n, where you either remember that the bottom becomes the root, or the root becomes the bottom, or the top stays as the exponent. Okay, so if we convert those, that's going to be 5 to the 2 over 3 times 5 to the, now it's a square root, so I'm going to put a tiny little 2 in here, which is going to be 5 to the 3 over 2. We can add our fractions, 2 over 3 plus 3 over 2. We're going to have a lowest common denominator of 6 over 6 plus over 6. We're going to times the top and bottom of this first fraction by 2. And we're going to times the top and bottom of this fraction by 3, which means that we're going to get 4 plus 9, which is equal to 13 over 6, and bring that back into the question. So we're going to get 5 to the 13 over 6. Circle our answer. So if we type that into the calculator, the cube root of 5 squared times the square root of 5 cubed, cube root of 5 squared times the square root of 5 cubed. We're going to get 32.69, so I'm going to write that in red near the question, 32.69. And then if I type in the question, the answer, 5 to the exponent, 13 over 6, I'm also going to get 32.69. Check our answer. Okay, D. So this time we have the square root of 5 cubed divided by the square root of 5 to the 4. So again, we can convert our roots. So we have 5 to the 3 over 2 divided by the square root of 5 to the 4, which is going to be 5 to the 4 over 2. Now, notice I'm going to clean that up a tiny little bit. 4 over 2. Now notice 4 over 2 is just 2. So why not do that first? So we're going to have 5 to the 3 over 2 divided by 5 to the 2. Now remember, if we have the same base, we're going to be subtracting exponents. So we have 3 over 2 minus 1 over 2, which is equal to simply 2 over 2. Excuse me. I need to erase that. 3 over 2 minus 2. 3 over 2 minus 2. Now the 2's over 1. We're going to multiply. We're going to find the lowest common denominator. We're going to get over 2 plus minus over 2. We're going to times the top and bottom of this fraction on the right by 2. And we're going to get 3 minus 4, which is equal to negative 1 over 2. So we're going to get 5 to the negative 1 over 2. Now we don't want to leave it with negative exponents, so it's equal to 5, it's equal to 1 over 5 to the 1/2, also equal to 1 over the square root of 5. Circle your answer. In grade 11, we're going to learn to not leave a square root on the bottom. But good. Sorry about that last error on that last question. Okay, 13F. Notice I forgot to check my answer on the last question. Try and do that on your own. So we have 5 to the 5 over 2 over 5 to the 4. So we're dividing fractions, so we can subtract our exponents. So we have 5 over 2 minus 4 over 1. The lowest common denominator is 2, so over 2 minus over 2. We're going to times the top and bottom of the second fraction by 2, which is going to be 5 minus 8, which is equal to negative 3 over 2. So the answer will be 5 to the negative 3 over 2. And nobody likes negative exponents, so 1 over 5 to the 3 over 2. Now keep in mind, your teacher might ask you to leave it in radical form or exponent form. So if we need to turn it to radical form, we can say 1 over the square root of 5 cubed, using our formula from the previous page and the previous questions. Circle your answer. I like to circle both answers just in case. Okay, on the calculator we have 5 to the exponent, 5 over 2, divided by 5 to the 4. I hope you're always checking your answer on your calculator while I am. And near the question, that is equal to 0.89. And then on the calculator we can do 1 divided by the square root of 5 cubed. And we also get equal to 0.89, so we know that we are correct. Okay, G. 13G, we have 2 to the 1 over 4 over 2 to the negative 1 over 2. So again, we're subtracting the exponents, but be really careful. We have this negative exponent. I don't like negative exponents, so I would rather bring it to the top. So I can say 2 to the 1 over 4 times 2 to the 1 over 2, bringing the thing with the negative exponent to the top and making the exponent positive. Then we can simply add the exponents. So feel free to add the exponents off to the right, but 2 to the 1/4 times 2 to the 1/2. 1/4 plus 1/2 is simply 3/4. So we have 2 to the 3/4. Again, we could convert it. That is the 4th root of 2 cubed. Okay, on the calculator we have 2 to the exponent 1 over 4 divided by 2 to the exponent negative 1 over 2. And we're going to get the answer equaling 1.68. And then I can type in the answer, 2 to the exponent 3 over 4, and I'm also going to get 1.68, which means check our answer, we did it correctly. Now off to the right, I'm going to do it a little bit differently. I could have subtracted my exponents. So I'm going to get 2 to the 1 over, just the exponents. So if I do 1 over 4 minus, subtracting the exponents, but this time it's negative 1 over 2, which is just the same as 1 over 4 plus, if we have two negatives side by side, we can use the rule same plus, 1 over 2, and we're going to get 3 over 4 either way, adding fractions with the lowest common denominator. Notice I skipped that step. Okay, H. So we have, open bracket, 5 to the 2 over 3, all to the 1/4. So we have exponents to exponents. We're going to multiply those exponents. 2 over 3 times 1 over 4 is just equal to, cross cancel, we can divide the top and bottom by 2. And we're simply left with 1 over 6, which is just 5 to the 1 over 6, and also equal to the 6th root of 5. Circle our answers. So if we type that into the calculator, open bracket, 5 to the exponent, 2 over 3, close bracket, to the exponent, 1 over 4, equals. So we're going to get 1.3, so near the question I'm going to write 1.3. And then I'm going to type in the answer, 5 to the 1 over 6, and we also get 1.3, which means we know we're correct. Some of you may be thinking, we're not allowed a calculator on a test. Yeah, obviously, who cares? We're not checking to see whether or not you know how to use a calculator. We're checking to see if you know how to check your answer, therefore building your skills on your own so you build that confidence when you go into the test without the calculator. Okay, I. So we have 8 to the 2/3 times 16 to the 3 over 2. So we don't have the same base. We need to get the same base. So we have to use a process called change of base. So we know that 8 off to the right is equal to 2 cubed. And we know that 16 is equal to 2 to the 4. We have to get the same base. So I can take the 8 and I can replace it with 2 cubed to the 2 over 3 times
2 to the 4 to the 3 over 2. I can then multiply my fractions. 3 times 2 over 3. 3 divided by 3 is 1, times 2 is 2, so we get 2 squared. And 4 times 3 over 2, I'll do that one off to the right. 4 times 3 over 2, we can cross cancel, so we can divide the top and bottom by 2. And we're just left with 6, which is times 2 to the 6. Then we have the same base, so we can add the exponents, so we get 2 to the 8. And 2 to the 8 is simply 2 to the exponent 8 is 256. So keep in mind, we should be able to do that with our fingers. 2, 4, 8, 16, 32, 64, 128, 256. Therefore, 2 to the 8 is 256, counting with our fingers. So let's try it on the calculator. 8 to the exponent 2/3 times 16 to the exponent 3 over 2, and we're going to get 256. So I'm going to write 256 near the question, and our answer is therefore correct. So notice I threw that little idiosyncrasy in. Make sure that you're very comfortable with change of base. We haven't done very much change of base yet today. There will be a little bit more change of base soon, but keep in mind that is a concept. If you're having any difficulty with change of base, please go back to the previous notes in previous grades, like grade 9 and grade 10, exponent laws, down below. I'd just like to make a quick note that I forgot to do question E. So there is no question E. Sorry about that. Okay, question number 14A. Is this a perfect square, perfect cube, neither or both? Well, first thing I'm going to do is I'm going to do a whole bunch of work off to the right. So 1 squared equals 1. 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25. And I'll continue that process in the future once I need more. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So we know that the first question, 125, is just 5 cubed. Now, it's asking us, I'm going to do a prime factorization tree on the 125. So way off to the right, 125 is 5 times 25, which is 5 times 5. Now, because we have 3 identical factors, we know that that's why it's a perfect cube, 5 cubed. Okay, B. Oh, and by the way, it doesn't have an even number of factors, so it can't be perfect square. So, by the way, a perfect cube is a cube, all with side lengths of 5. 5, 5, 5. And the volume would be 125, and that's why it's a perfect cube. And it's not a perfect square because there's no 2 identical numbers that multiply together to make 125. Okay, B, 64. So, we know from off to the right that 4 cubed is 64. So we know that it's a perfect cube. But I'm going to work on my squares. So 6 squared is 36. 7 squared is 49. 8 squared equals 64. Sorry about that. So then we know that it's also a perfect square. It's 8 squared, a perfect square. If we had done prime factorization, 64 is 8 times 8. Again, we have 2 identical factors, an even number of factors. So we know that it is a perfect square with a square with side lengths of 8. And then we also know 64 is a perfect cube because it's 8 times 8, which is 4 times 2, and again 4 times 2, and again 2 times 2, and again 2 times 2. So it's a perfect cube because we have a triple of 2's and another triple of 2's. Therefore, it's also a perfect cube, which is simply 4, 2 times 2, times 4, 2 times 2, times 4, 2 times 2. So we have 3 4s. Therefore, it's a perfect cube, 4 cubed. Okay, C, 99. If we do a prime factorization tree on 99, we're going to get 11 times 9. It is neither. Is that how you spell neither? All right, so working down the page, we have D. So we have 3 to the 4. Well, 3 to the 4, if I separate exponents, is simply 3 squared squared. So we have something squared, which is 9 squared. Therefore, it's a perfect square. Now, I could have multiplied it out. 3 to the 4 is 3 times 3 times 3 times 3, which is 81, which is also just 9 times 9. Now, we could further prime factorize and get all the way down to 3's, but we may as well just stop there. We know we just have a square with side lengths of 9. Okay, E. So we have 1 to the 5. Well, we don't have a squared exponent, we don't have a cubed exponent, so neither. Okay, G. We have 5 to the 6. Well, again, we can separate the exponents into be 5 squared cubed, which is just 25 cubed, which is a perfect cube. And we also could have separated it being 5 cubed. I'm going to retype that. 5 cubed all squared, separating our exponents, reversing exponent laws. Now, because we learned earlier that 3 times 2 is 6, we can separate it in either way we want. 5 cubed is 125, and that's still squared, so we know we have both a perfect square and a perfect cube. Okay, H. So I'm going to do that a little bit up to the right in a nice column. So we have 4 cubed. Now 4 cubed is 64. 4 times 4 times 4. And we learned earlier that 64 is 8 times 8. So we know it's 8 squared. And I'm going to do it differently. So we have 4 cubed. I'm going to perform change of base. So 4 is simply 2 squared, still cubed, which is just 4 cubed. A perfect square and a perfect cube. So lots of different methods that we did there. We did a lot of change of base, a lot of exponent rules, a lot of prime factorization, and a lot of reversing exponent rules. So notice the first thing I did was just write down everything I know about perfect squares and perfect cubes to get my brain going, make me start thinking about what they are, the performance of change of base, and working with exponents in the reverse order. And I accidentally forgot F. So we have question F, which is 2 to the 5. And that can't be broken down, so neither. Okay, we have 15A. So 4 squared. The question says change the base. So 4 is simply 2 times 2, or 2 squared. Therefore, we can replace the 4 with 2 squared and also say squared, carry down the squared, and we can multiply the exponents together, 2 to the 4. So, keep in mind, we can check our answer on our calculator, which I forgot to do the whole last question, it seems. 4 squared is 16, and 2 to the 4 is also equal to 16. Therefore, we know that we are correct. Okay, B. So now the question says 16. So 16 is 4 squared, circle our answer. It's also 2 to the 4. So Check our answer on our calculator. 4 squared, 16. 2 to the 4, also 16. Therefore, both equal to 16. Check mark. The question on the test might be change the base to a certain base that they tell you. They may say change the base to any base you like. But these are all just skills that we are learning for the future. Okay, C, 81. In the last question, I could have done a prime factorization tree on 16 and got 4 and 4, therefore it's 4 squared. Or I could have done 16 is 2 times 8, and 2 times 4, and 2 times 2, which means that it's 2 to the 4. So, not going to do that again. 81 is simply 9 squared. It's also 3 to the 4. Oh, fine, I'll do it. Off to the right, 81 is 9 times 9, so it's a perfect square, but it's also 3 times 3 and 3 times 3. With 4 3's, therefore 3 to the 4. Okay, D, we have 9 cubed. So 9 is simply 3 times 3, so we're going to replace 9 with 3 squared, still cubed, multiply the exponents together, 3 to the 6, circle our answer. So on our calculator, 9 cubed is 729, and 3 to the 6 is also 729, so check your answer. I believe I forgot to check my answer in the last one, but 9 squared is 81, and 3 to the 4 is also equal to 81, so check our answer. Okay, E. So we have 18. Change of base. Well, 18 is not a perfect square or perfect cube, but we know it is 3 times 6, and 6 is 3 times 2, which means 18 is going to be 3 squared times 2 to the 1. Change of base. What are we doing this for? Practice for higher level math. Okay, we have F. So we have 4 cubed times 8 squared. Now 4, as we learned earlier, is simply 2 squared, still cubed, times 8. 8 is 2 cubed. Feel free to do a prime factorization tree on 8. Then we can multiply the exponents together, so we have 2 to the, 2 times 3 is 6. And again, 2 to the, 3 times 2 is 6. And we're left with 2 to the 12. Circle our answer. Leaving it in exponential form, there's no reason for you to figure out what that is. Now, 2 to the 12 is equal to 4,096. And the question, 4 cubed times 8 squared, is also equal to 4,096. So we know we have a correct answer. Okay, 16a, simplify. 16a. So we have 2 cubed times 2 to the 4 over 2 to the 5. So we're going to start by doing the top. So we have 2 cubed times 2 to the 4. We're multiplying with the same base. Therefore, we're going to add the exponents. So we get 2 to the 7 over 2 to the 5. Then we're dividing with the same base. We can subtract the exponents, and the answer will simply be 2 squared, or 4. Circle our answer. Now we're going to type the question in. Now it's just safer to put brackets around the top and brackets around the bottom when typing these questions in. Now they're actually unnecessary, but if there's a multiplication on the bottom, they're absolutely necessary, and if there's a plus sign on the top or the bottom, they're both necessary. So open bracket, 2 cubed times 2 to the exponent 4 divided by, brackets around it, divided by, open bracket, 2 to the exponent 5, brackets around it, enter, and we get 4. Therefore, we know our answer is correct. Okay, B. We have 3 to the 4. Excuse me. 3 to the 4 times 3 to the negative 3 over 9. So I'm going to do a couple things in the first step. First things first, I have a negative exponent. I'm going to take the thing with the negative exponent and bring it to the bottom, make the exponent positive. Now I have a 9 on the bottom. I'm going to do change of base. 9 is just 3 squared. And I'm going to leave 3 to the 4 on the top. So we can say 3 to the 4 over. Now we're multiplying on the bottom with the same base. So 3 to the 4 over 3 to the 5. Excuse me, 3 to the 5. And then therefore we're going to subtract exponents. Now you can subtract from the top, and 3 to the 4 over 3 to the 5 would be 4 minus 5 would be negative 1. So we're going to get 3 to the negative 1. Then we have to bring it back down to the bottom anyways and make the exponent positive. 1/3. We should have just subtracted from the bottom. 5 minus 4 is 1. But I will leave you to go back to grade 9 exponent laws and go work through those carefully, watching the notes, homework, and video. So let's type this into the calculator. Brackets are on the top, brackets are on the bottom. On the calculator, open bracket, 3 to the exponent 4 times 3 to the exponent negative 3, close bracket, divided by 9, brackets around it, equals 0.3 repeater, which is 1/3. Check our answer. Okay, C. So we have 4 squared times 16 cubed, cubed, over 128 squared. So we need to know which base we can use. So 4 is equal to 2 squared. 16 is equal to 2 to the 4, but also equal to 4 squared. Now 128 is only equal to 2 to the 7. I'm going to check that on the calculator, 2 to the 7. Good, so because 128 can't have a base of 4, we have to use base 2. So I'm going to replace the 4 with 2 squared, brackets around it, still squared, times 16 is 2 to the 4, brackets around it, to the 3, over 2 to the 7. So on the bottom, on the top, we can multiply the exponents. So we're going to have 2 to the 4 times 2 to the 12 over 2 to the 7. Then on the top, we're multiplying with the same base. We can add the exponents. We get 2 to the 16 over 2 to the 7. Then we're dividing with the same base. So we can subtract the exponents. 16 minus 7 is 9. And 2 to the 9 is simply 512. Circle our answer. Check our answer on the calculator. Brackets are on the top, brackets are on the bottom. Okay, we have, open bracket, 4 squared times 16 cubed, close bracket, divided by 128 squared, equals, whoops, didn't do the divided by, second insert divided by, enter, and I'm going to get 4. Interesting. Okay, so this is a great option. Okay, so first things first, I'm going to look at my question. Make sure I typed into the calculator correctly. 4 squared times 16 cubed, yes. Then I'm going to check the bottom, 128 squared, yes. So up near the question, I'm going to say equals 4. So I'm going to wonder why my answer's wrong. This allows me to go and check each individual step. So 4 is definitely 2 squared, and 16, so I definitely put 2 squared in for 4 correctly. Then 16 is definitely 2 to the 4, so I replaced 16 with 2 to the 4, and that was still cubed, correct. Then 128, let me check that again. 128 is equal to 2 to the 7. That is, oh, I see, I forgot the squared on the bottom in the second step. I'm going to do that in blue. So, brackets around the bottom, squared. Again, brackets around the bottom, squared, which means it's not going to be 2 to the 7 on the bottom, it's going to be 2 to the 14. Which means both my answers are incorrect. I'm going to put single lines through them, keeping them to show that I need to be more careful. Then I can subtract my exponents, so we're going to get 2 squared. 16 minus 14 is 2, which is equal to 4. Circle our answer, and we know we're correct. So, notice, I still make silly mistakes. It's going to happen all the time. Be very careful. Always write down the answer you got. Never erase it. Always cross it out with a red X to show that you understand that we make mistakes all the time and that we have to be very careful in each individual step. And by checking our answer, it allows us to see if we did any individual step incorrectly, allowing us to more carefully walk through our steps and make sure each one is perfect, then focusing in on the step that we are least confident about, and then figuring out the correct answer. Okay, at the top we have D, open bracket, 2x cubed y squared times 6xy to the 4 over, open bracket, 4x cubed y. So on the top, we're going to multiply our coefficients. So 2 times 6 is 12. Then we have, I'm going to give the exponent of x in the second set of brackets a 1. I'm going to add the exponents of the x's. X cubed times x to the 1 is x to the 4. Then we're going to get y to that. 2 plus 4 is 6. Over the same thing, we haven't touched it. Now 12 divided by 4 is 3. Then we can subtract our exponents. 4 minus 3 is 1, so we have x to the 1. The 1's unnecessary. I put it there for fun. Then we have y to that. I'm going to give the y on the bottom an exponent of 1 to remind me that I subtract the exponent. 6 minus 1 is 5. Circle our answer. Remember, we can choose an x value and a y value. So for example, you could choose x equals 3 star. It doesn't. We would do it for fun. And y equals 4 star. It doesn't, but we do it for fun. Then we put it into the question, both of them, put them in the answer, both of them, and make sure that we did it correct. Okay, we have E. So, we have 8x cubed y squared all squared times 6xy to the 4 to the negative 2 over 4x cubed y. So, first things first, I have a thing with a negative exponent, so I'm going to deal with that first. I could distribute the negative 2 into the brackets, but I'd much rather bring the whole thing down to the bottom. So, if I bring that thing down to the bottom, I'm going to have 6xy to the 4 all squared, then 4x cubed y, then 8x cubed y squared, still squared, which I haven't touched yet. All I did was bring the thing with the negative exponent down to the bottom. In the future, feel free to just cross it off and put it down below without rewriting the whole question. Either way, we haven't touched the top. Oh, right, so I'm going to work on the top. So 8 squared, distributing the exponent, is 64. I'm going to skip a line because it's getting a little bit messy. So on the top, we have 8 squared, which is 64. Then I'm going to multiply the exponents. We have x to the 3 times 2 is 6. Y to the 2 times 2 is 4. Over. Now I can't multiply the numbers in front first because I have to deal with the bracket's exponents. So I'm going to start off with the first term, which I haven't touched. 4x cubed y. Then I'm going to distribute the exponent. 6 times 2 is 36. X, I'm going to give the exponent of x on the inside of 1 to remind me that I multiply the exponents. 1 times 2 is 2. Y to that, I'm going to clean up that 2 a tad. Y to the 8. So I'm going to want to work on the bottom first. So 4 times 36 is 144, so I'm left with 64, x to the 6, y to the 4, over 144. Now I can multiply on the same base. X cubed times x squared is going to be x to the 5. And y, I'm going to give an exponent of 1 to remind me that I add the exponents. And I'm going to have y to the 9. So I can simplify the fraction. I'm going to divide the top and bottom by 4 because I know I can. 16 divided by 4 is 4, and 144 divided by 4 is 36. Then I'm going to divide the top and bottom by 4 again. So now I'm going to set up my fraction. And if I simplify 4 over 36 and divide the top and bottom by 4, I get 1 over 36. Then on the top I have x to the 6, on the bottom I have x to the 5, so I can subtract the exponents and get x to the 1. Then on the top I have y to the 4, and on the bottom I have y to the 9. Well, I can subtract from the bottom or subtract from the top. I'm going to subtract from the top, so we're going to get y to the 4 minus 9 is negative 5. Then I'm going to bring the thing with the negative exponent down to the bottom and say y to the 5. Notice I could have just subtracted from the bottom. Now I could rewrite it, but I'm just going to circle my answer. Again, you could choose an x value and a y value and put it into the question and put it in the answer, but let's not. That question was a lot more difficult. So, a lot of combination steps. Multiplying the exponents, adding exponents, subtracting exponents, working with fractions, working with multiplication. Great.
Okay, 17a, we have x squared equals 9. I'm going to rewrite that question. So, we always want to do the reverse operation to both sides. So we have squared, so we need to square root both sides. Now, the definition of the square root of x squared is equal to the absolute value of x, which you don't need to know yet, but is equal to the plus or minus of x. Therefore, x equals plus or minus 3, the square root of 9. We have to get plus or minus because if we check our answer, positive 3 squared equals 9, and also negative 3 squared also equals 9. Check mark. That's why it's going to be plus or minus. X equals plus or minus 3. Okay, 17b, we have x cubed equals negative 8. So, this time we have a cubed. In the last question, we had a squared, so we're going to square root both sides. In this question, we have a cubed, so we're going to cube root both sides. So on the left-hand side, the cube root of x cubed is simply only x, and the cube root of negative 8 is simply negative 2. Circle our answer. Check our answer off to the right. Negative 2 cubed is negative 2 times negative 2 times negative 2. We have 3 negatives, therefore the answer is negative. And 2 cubed is 8, therefore our answer x equals negative 2 is correct. Okay, C, the square root of x equals 4. So, we want to do the reverse operation. So the reverse operation of square root is squared, so we want to square both sides. And the square root of x squared is just x, and 4 squared is 16. Circle your answer. Check our answer. The square root of 16 equals 4. Correct. So remember, if it's a squared, we do the opposite operation, square root both sides. If it's a cubed, we do the opposite operation, cube root both sides. If it's a square root, we do the opposite operation, square both sides. Okay, D. We have x to the 2 over 3 equals 16. So, I'm going to do the last question a little bit differently off to the right in a large box. So, because the square root of x is equal to x to the 1/2, because it's a square root and it's x to the 1, we learned earlier how to convert that. we're really squaring it because we're putting brackets surrounding it and squaring it. Because 1 over 2 times 2 is equal to 1, that means that we can cancel the exponents and the answer is just x. So now working on 17D, we want to take both sides to the reciprocal exponent of the variable. Now you may not be doing this stuff in grade 10, but it is a grade 10 skill, so we're going to be learning it now and then we'll be using it in the future. So again, we're going to take both sides to the reciprocal of the variable. If we flip 2 over 3, we're going to get 3 over 2, so we're going to take both sides to the 3 over 2. The reason why we're going to do that is because 2 over 3 times 3 over 2 is simply 1, and that will cancel the exponents on the right-hand side. Therefore, x is equal to 16 to the 3 over 2. So now we can convert that using our pattern. So if you remember from last chapter, x to the m over n equals the nth root of x to the m. Not last chapter, just earlier in this chapter. So we can convert it. So that means that's going to be the square root of 16 cubed. Now, does anybody know what the cube of 16 is? No, we want to do the square root first. The square root of 16 is 4, so x equals 4 cubed. And 4 cubed is 64, therefore x equals 64. We can check our answer. 64 to the 2 over 3 is equal to the cube root of 64 squared. And the cube root of 64 is 4, and still squared is equal to 16. And the right-hand side said 16 in the question, so x equals 64 is correct. Okay, please note, when I start the next question, I accidentally called it D when it's accidentally supposed to be E. So when you get onto this next page, notice that I accidentally called this question D when I was supposed to call it E. Sorry about that. Okay, 17D. So we have 2 to the x equals 4 squared. Well, we've never seen a variable in the exponent before, but what's stopping us? So we can perform change of base. We know 4 is equal to 2 squared. We have to get the same base. So 2 to the x equals, we can replace 4 with 2 squared and then still square it. So 2 to the x equals 2 to the, 2 times 2 is 4, multiplying the exponents together. Then when we clearly have the same base, if 2 to the x equals 2 to the 4, we simply know that x equals 4. Circle your answer. Check your answer. 2 to the 4 equals 4 squared, and 16 equals 16, so we know that we are correct. Okay, another one of those, F. So we have 3 to the x equals 27 squared. So this time, 27, we need to get it to be base 3, so change of base, we're going to get 3 cubed. 3 times 3 times 3 is 27. So we can replace 27 with what it is, 3 cubed, getting the same base as the other side. So 3 to the x equals, on the right-hand side, we can multiply the exponents together. 3 times 2 is 6. Then we have the same base, so x equals 6. Check our answer. 3 to the 6 equals 27 squared. So on our calculators, 3 to the 6 is equal to 729, and 27 squared is also equal to 729. Therefore, we know that we are correct. Okay, F, G. 2 to the x equals 2 to the 5. So this question is already done for you. We can clearly see that the exponent x just equals 5. If we have the same base, make the exponents equal to each other. Okay, H. We have 4 to the x plus 1 equals 8 to the 2x minus 2.
Okay, so we know that 4 is simply 2 squared and 8 is simply 2 cubed, getting the same base on both sides. 4 being 2 squared, still to the x plus 1, equals 2 cubed, still to the 2x minus 2. So we can multiply the exponents together. We have 2 to the 2x plus 2 distributing equals 2 to the 6x minus 6. So notice, we have the same base, we can make the exponents equal to each other. So 2 to the x plus 2 equals 6x minus 6. So if we subtract 2x from both sides, 2 equals 4x minus 6, and if we add 8 to both sides, then 10 equals 4x. We can divide both sides by 4. Therefore, x equals, if I simplify the fraction, 5 over 2. Or 2.5. What a funny answer. Well, if we put it back into the question, 4 to the x plus 1 equals 8 to the 2x minus 2, then we have 4 to the, so the answer 5 over 2 is 2.5. We substitute into the equation, 2.5 plus 1 is 3.5. And then we have 8 to the 2 times 2.5 is 5, minus 2 is 3. And that's why it's wrong. So 4 to the exponent 3.5 is 128, and 8 cubed is 512. So those aren't the same, which means our answer is correct, which gives us a great opportunity to go back through our steps and find out which step was incorrect. So first things first, I'm going to put check marks beside all the correct steps. So 4 is definitely 2 squared and 8 is definitely 2 cubed. So we definitely put 2 squared and 2 cubed in for 4 and 8 correctly. We then multiplied the exponents together. 2 times x is 2x and 2 times 1 is 2. On the right hand side, 3 times 2x is 6x and 3 times negative 2 is negative 6. Then we can make the exponents equal to each other. We can, there it is. I was thinking too far ahead and I added 8 to both sides when I should have added 6. So I'm going to redo this section. So 2 equals 4x minus 6. We're going to add 6 to both sides. Therefore 8 equals 4x. Divide both sides by 4. And x equals 2. Circle your answer. So I'm going to cross out our original. Now I'm going to resubstitute. So if x is equal to 2, that means the left-hand side will be 4 cubed. X plus 1, 2 plus 1 is 3. On the right-hand side, we have 8 to the 2 times 2 is 4, minus 2 is 2. And 4 cubed is 64. And 8 squared is also 64. Therefore, our answer, x equals 2, is correct. I really wanted to make that mistake happen. I didn't actually mean to make it happen. Just notice, I thought ahead. When I, in blue, added 8 to both sides, I had thought if I add 6 to both sides, 2 plus 6 is 8, and that will just sometimes happen. So, checking your answer is a great way to look through all of your steps and make sure that each one is correct. Working on the one that you are least confident about first, working towards the final answer. So keep in mind that is a much more difficult question than most grade 10s are going to see. You usually see it in what's called exponentials in grade 12. I just wanted to introduce you to a topic like that in this section of squaring, square rooting both sides, and making your exponents equal to each other. Okay, 18a. Estimate the following square roots. Square root of 6. So what we know is that we can draw a number line and put square roots that we know. So a number that we know below square root of 6 is the square root of 4, and above is the square root of 9.
and the square root of 4 is 2, and the square root of 9 is 3. Now, square root of 6 is going to be a little bit closer to 4 than it is going to be than to 9. So, the square root of 6 will be closer to 2 than to 3. So we just want to make an estimate. So I'm going to go for 2.3, circle my estimated answer. Then check it on the calculator. It's the square root of 6. The square root of 6 is equal to 2.4. So incredibly accurate. On these tests, they will usually allow for 2.3, 2.4, but not 2.5. 2.5 is a little bit big because 6 is closer to 4 than it is to 9. Okay, square root of 24. Square root of 24. So again, draw a number line. I forgot my arrow tips on my number line in the last question. Now, the square root of 24, well, we know the square root of 25 is 5, and we know the square root of 16 is 4. Now, 24 is way closer to 25, so it's probably going to be like 4.9. Circle your answer. Check it on the calculator. Square root 24 is equal to 4.89, which is 4.9, incredibly accurate. Okay, the cube root of 61. Cube root of 61. So this time we're going to draw a number line, but this time it's going to be cube roots. So the cube roots that we know 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So we're going to put the cube root of 64 and call it 4, and then the next lower one, the cube root of 27, is 3. Now the cube root of 61 is way closer to 64, so it's going to be like 3.9. Circle your answer. So on the calculator, we can test the cube root of 61, and the cube root of 61 is equal to 3.9. Incredibly accurate. Okay, so then in B, when they ask us to arrange things from least to greatest, we have the square root of 32, we have the square root of 18, and the square root of 50. So in these questions, we would just do exactly what we did above. Now we can clearly see that the order should be root 18, then root 32, then root 50. But, so I'm going to put that in that order. Square root 18, square root 32, square root 50. And that is in order from least to greatest. So that was incredibly simple. But what if they gave us numbers like the cube root of 61, the square root of 64, and the cube root of 125? Well, we'd have to do a bunch more work. So we know from above that the cube root of 61 is simply 3.9. We know that the square root of 64 is 8, and we know that the cube root of 125, well, 5 cubed is equal to 125, so the cube root of 125 is 5. Then we can arrange them from least to greatest. So we can say that it is the cube root of 61, then the cube root of 125, then the square root of 64. And that would be in the order from least to greatest. That will be question C, excuse me. Okay, question number 19. So, we have find the perimeter of this square. So we have an area of 98 inches squared and side lengths of S because they're the same. So area equals length times width, and specifically in a square, a equals s squared. The side length times the side length, s squared. Now we can take the area, 98, and substitute it in for the area. Then we can reverse the operation of squared by square rooting both sides. Therefore, s equals the square root of 98. And it's plus minus. But we can reject the negative, so s just equals the positive root of 98 because they're side lengths of a square. Now, is this our final answer? Well, we have to take 98 and do a prime factorization tree on it. So that's going to be 49 times 2. Therefore, that's going to be 7 times 7. So s equals the square root of 7 times 7 times 2. We have two identical numbers underneath the square root. Therefore, s equals 7 root 2. Circle our answer, and I'm going to draw a new diagram and put it in the diagram, not as big. 7 root 2, 7 root 2. So that is the side length from the area information. Now we want to find the perimeter. So P equals, we have to add up all the sides. So if it's a square, all the side lengths are the same. They're all 7 root 2. Now I could do 7 root 2 times 4, but I'm just going to do 7 root 2 plus 7 root 2 plus 7 root 2 plus 7 root 2. So P equals, if I have 7 root 2's plus 7 root 2's plus 7 root 2's plus 7 root 2's, that just means I can add the coefficients. I have 28 root 2's. And that will be in inches. Circle our answer. So lots of the times they give you information that you have to use one formula for to eventually use that information that you found from that formula to use in another formula to find something else. Okay, number 20. So we have a cube, so I'm going to draw a cube, draw a square, draw another square, connect your corners. And I'm going to put ticks on all the equal lines because it's a cube. And we know the volume is 250 centimeters, meters cubed. So the side lengths are all S, S, S. So the formula for the volume of a cube is length times width times height, but specifically when the volume, when all the length, width, and the height are the same, S, our side length, we can just say S cubed. We can then take our volume and substitute on the left-hand side of the equation, 250 equals S cubed, and we can reverse a cubed by cube rooting both sides. Therefore, S equals the cube root of 250. So we're going to do prime factorization on the 250. So 250 is 2 times 125, is 5 times 25, is 5 times 5. So we can then, I'm just going to erase those, they were a little bit messy, 5 times 5. We can then write all the numbers underneath the cube root, 5 times 5 times 5 times 2. Then we have 3 5's underneath the cube root, so 1 can come out. S equals the 5 cube root of 2. Circle our answer. So check our answer. V equals S cubed, which is going to be V equals 5 cube root of 2, brackets around it, cubed. And 5 cubed is 125. And the cube root of 2 cubed is just 2. So V equals 125 times 2, and V equals 250. Check our answer. Okay, question 21. Find the area of the square. So let's take a square with equal length and a diagonal of root 2. Find the area of this square. So first of all, the formula for area is length times width, but specifically in a square with the same side lengths, we get A equals S squared. Now we need to figure out what these
side lengths are. So notice we have a right angle triangle, so we can start off with Pythagoras. A squared plus b squared equals c squared. So our side lengths are s, so s squared plus s squared equals c root 2 squared. So on the left-hand side, we have 2s squared. S squared plus s squared is simply 2s squared. On the right-hand side, the square root of 2 squared is just 2. We can divide both sides by 2, so s squared equals 1. Then we can square root both sides. S equals plus minus 1, but positive because it's a side length, and s equals 1. Therefore, the area is just equal to 1 squared or equal to 1. Oh, I forgot the units. Root 2 centimeters. Therefore, our area is 1 centimeter squared. Circle our answer. Okay, 22. So, find the radius of a sphere given the following equation related to volume. So, we have given information, V equals 268.09 centimeters cubed. And we have a formula, V equals 4 over 3 pi r cubed. So we have the volume. We can substitute in the left-hand side of the equation. So 268.09 equals 4/3 pi r cubed. And we have to solve for r. So we can start with the 3 on the bottom. We can times both sides by 3. Then we have 3 times 268.09. Sorry, 3 times 268.09 is equal to 804.27 equals 4 pi r cubed. So now we have a 4 in front, so we're going to divide both sides by 4. Divided by 4, we're going to get 201.0675 equals pi r cubed. We're then going to divide both sides by pi over pi over pi. Then we can cancel the pi's on the right-hand side, so we can divide it by pi, and then we're going to get 64.00 equals r cubed, and we can reverse a cubed by cube rooting both sides. Therefore, r equals 4. Then we can check our answer by taking it and putting it back in. So V equals 4/3 pi r cubed. V equals 4/3 pi 4 cubed. V equals 4/3 pi times 64. V equals 4 divided by 3 times pi times 64 is equal to 268.09 centimeters cubed. I forgot my units in my answer, 4 centimeters. Don't forget your units in your answers. All right, question number 23. Always drawing a diagram if you can. So notice I just mentioned always draw a diagram if you can. I should have drawn a sphere in the last question. But in this question, find the time it takes to drop a ball. So we're going to drop a ball off a 122.5 meter high building from the following equation. H equals 4.9 t squared. This is actually Newton's equation that he figured out that planets are actually falling towards the Earth, yet going so fast in a circle that they form an orbit. So we're given 125. We can put 122.5, the height, on the left-hand side. We can divide both sides by 4.9. Therefore, t squared equals, on the calculator, 122.5 divided by 4.9 is equal to 25. We can square root both sides, and t equals 5 seconds. Height in meters, time in seconds with that formula. A great formula to allow you to calculate the time it takes to drop from a certain height, or if you know the time, like we're going to check our answer right now. So h equals 4.9 t squared. If I take that t and I substitute it into the equation, h equals 4.9 times 25, and h therefore equals 122.5 meters. Check our answer. Okay, 24a. Solve for p if n equals 7. So we can write down the formula. P equals 2, open bracket 2, close bracket to the n. And they're saying that n equals 7. So P equals 2 times 2 to the 7. Now, what does BEDMAS tell us to do first? The multiplication or the exponent. Well, exponents first. So 2 to the 7 is 128. So P equals 2 times 128. And therefore P equals 256. Okay, B. Oh, forgot to check my answer? Well, no. Checking your answer on a question like this is literally impossible because you're really just doing exactly the same thing that you did. Okay, in B, so we have P equals 2 times 2 to the n, where this time P is 1,024. So we're going to take 1,024 and put it on the left-hand side. So 1,024 equals 2 times 2 to the n. Then we're going to start by dividing both sides by 2 because we have to. 512 equals 2 to the n. Now we're going to do change of base. So 512 is equal to, you just sit there on the calculator and try. You'd be like 2 to the 9, or sorry, 2 to the 8 equals 256. Oh, 2 to the 10 equals 1,024. Oh, okay. It must be 2 to the 9. Try it on your calculator. 2 to the 9 equals 512. So on the left-hand side, we can replace 512 with 2 to the 9. Therefore, we have the same base, so we can make our exponents equal to each other. N equals 9. Okay, C. This time we have P equals 2 1/2 to the n, where P equals 1 over 16. So I'm going to work on that 1 over 16 right now. 1 over 16 is 1 over 2 to the 4. I know that I need a base of 2 because there's 2's everywhere. And it's actually 2 to the negative 4. So I'm going to replace that on the left-hand side. So 2 to the negative 4 equals 2 open bracket. Now 1/2 is simply 1 over 2 to the 1, which is equal to 2 to the negative 1. So I'm going to replace that, 2 to the negative 1 to the n. So now I'm going to be doing a bunch of stuff. So on the left-hand side, I'm going to leave 2 to the negative 4. Above, I'm going to give the 2 in front an exponent of 1. So that's equal to 2 to the 1 times 2 to the, then we're going to multiply our exponents, negative n. So we can say 2 to the negative 4 equals, on the right-hand side, we can add the exponents together. 1 plus negative n is just 1 minus n. Then we have the same base, so we can make the exponents equal to each other. Then we can minus 1 from both sides, so negative 5 equals negative n. Then we can divide both sides by negative 1. And n simply equals 5. Okay, so keep in mind, those last questions that we were doing were much more difficult, much more higher level math, but they might throw them at you, so be careful. This was our exponents review, all the way from radicals, changing forms, working with exponents and all the different exponent rules, doing combination rules, then seeing a bunch of word problems. Exponents review completed.